This video provides a demonstration of G-MITSIM, the Generative Multi-Agent Intelligent Traffic Simulation. As shown in the comparison chart, the platform represents a shift beyond the constraints of standard traffic models and into the era of generative AI. Traditionally, simulators function as black boxes with static topologies that are difficult to modify once compiled. In contrast, G-MITSIM is generative and dynamic, capable of adding nodes, links, and lanes in real time through chat commands. The control interface is also redesigned. Instead of relying on manual menus, buttons, and complex scripting, the system introduces an NLP-based God mode that enables simulation control using natural language commands. While standard driver logic relies on reactive physics models, such as gap acceptance, G-MITSIM utilizes cognitive agents capable of reasoning and strategy through large language models. Traffic signals operate not as fixed timers, but as fully adaptive AI agents that respond to queue flow on demand. Regarding output, the platform goes beyond raw CSV numbers to provide explainable AI, offering decision logs that detail the reasoning behind each action. Looking at the system architecture, the platform takes inputs such as OSM maps and CSV scenarios, routes them through a core physics engine for safety, and then processes them through the Generative AI Core, which consists of two distinct layers. AI Layer 1 is the Traffic Management Agent, or God mode. Through OpenAI integration, the simulation understands natural language context. The AI can modify the network structure in real time by adding or removing links, nodes, and lanes, or by adjusting parameters such as speed limits and lane dedications for specific vehicle types. God mode operates as an active controller, setting origin, destination demands, monitoring flow, and directing corrective actions. It can change routing strategies, hold traffic, create accidents, and clear them on command. AI Layer 2 is the autonomous AI driver, represented visually as the pink vehicle. These vehicles are driven entirely by a large language model reasoning loop. They perceive their surroundings, leader distance, lane availability, and obstacles, and generate a text-based driving strategy. They function within an intelligent ecosystem, communicating with agents for intersection-by-intersection routing advice, while still being capable of following predefined paths. Standard physics-based vehicles can be taken over mid-simulation and converted into reasoning LLM agents instantly. The output layer ensures data integrity, exporting comprehensive files that allow any session to be replicated exactly. The system dashboard displays the 6 technical pillars of the platform. Under visualization and physics, the engine renders dynamic intersection polygons and real-time heat maps. It controls vehicles using IDM and MOBIL models, while supporting advanced behaviors such as CACC platooning and emergency corridors. Additional visualizations include time, space diagrams, and cyan indicators for accidents and obstacles. In AI and control, the platform supports gymnasium reinforcement learning environments, eco-dexter routing, and vehicle-to-infrastructure communication. For network topology, the system supports native imports from OpenStreetMap and SumoNet, XML files featuring dynamic node healing and parallel flow intersection logic. For data and I/O, the system captures deep analytics, including emission calculations, fundamental diagrams, and detailed pink vehicle reports, while providing full control through CSV scenario configurations and interactive zoom and pan tools. All logic layers and API connections are active, and the remainder of the video demonstrates each of these features in action.